Hi, I want to suggest a method for notating Collatz convergence with precision. This can be done with an elementary formula. I've chosen a couple of symbols, the equiangular symbol and the familiar pipe symbol. And the way to read or say this formula is simply A and C or B and C are convergent with respect to a given output n. Now, this convergence identity is true for all odd integers equal to or greater than 1. The reason for this is given by the three operations seen here, and this is really the work, shall we say, that describes the input-output system that produces the convergence identity. These three operations are the underpinning of the stated identity, and their meaning I've explained elsewhere. So let's take the convergence identity apart for the two and only two cases that there are. This one I call A convergence, and it states that terms A and C are convergent with respect to a given output n. The example I'm giving is 19 and 117 are convergent with respect to 29. So I consider 19 to be an A term because it performs operation A I previously showed, which is an operation that increases the output. And the output is 29. Now, 29 is also the output of 117. So 117 is an operation C. So we have an operation A and an operation C. They're deeply related in that they produce the same output. And this means that 19, 29, and 117 are actually part of the same orbit. And I'll show you what I mean. So we see that so-called sequences beginning with 19, 29, and 117 all converge almost immediately on an even number. So that is what the convergence really means. B convergence is very similar to A convergence, the difference being that the first integer, in this case 33, is subject to operation B rather than operation A. But apart from that, it is the same idea entirely. So 33 and 101 are convergent with respect to 25. So if we look at the inputs, we have 33 and we have 101, and we can consider 25 to be the output. We see that the convergence implies the same orbit. The so-called sequences beginning with 33, 25, and 101 converge within a couple of steps with each other. I want to draw your attention to a property of A convergence and B convergence, and that is there is a fixed relationship between the two inputs. So in the case of A convergence, where the inputs are A and C, we see the relationship is 6A plus 3. So 19 times 6 plus 3 is 117. It's not arbitrarily to do with those numbers. It's every case. 6A plus 3. For B convergence, it's 3B plus 2. So, for example, 33 times 3 plus 2 is 101. but it's not exclusively true for those numbers, it's true for every B convergence. So those are the two fixed ratios which you will see through the number line for infinity for convergence in Collatz sequences. Well, because I'm able to demonstrate the convergence is an arithmetic property of every output, given the stated identity, which is A or B are convergent with C for a given output, and there is a given output for every case, from here it directly implies there is an inductive proof that all Collatz sequences are convergent, beginning with the basis case of 1 is convergent with 1 for output 5.